People, let's continue with coordination compounds. Last topic that we did was synergic bonding. Today is the last lecture. Chota topics are left. Please write down on a new page. Stability of coordination compounds. Right on. First point. There's only one point. The stability of coordination compound. Stability of coordination compounds is measured in terms of stability constant. Please write down the brackets. Beta n. This is similar to equilibrium constant. And I repeat, this is also called as now people, how do we get this stability constant? Let's try and understand that. Let's say I have M as the central metal atom. You have a ligand which forms a bond with the central metal atom. So क्या बन जाएगा people? Let's say ML. This ML with one more ligand, this becomes ML2. If I write the stability constant for the first step or equilibrium constant for the first step, K1, how much will that be? It will be concentration of ML over concentration of M. Just like we used to write the expression for equilibrium constants. Similarly, what will you write the expression for K2? ML2 over ML into L. What will the next step be? Let's say if we are going till coordination number 4. So ML3 plus L. This will be what people? ML3. K3 can be written as, pardon me, ML2 tha na idhar. Yeah. So ML3 over ML2 and L, yes or no? And last, since I repeat, we're going till coordination number 4. So this becomes ML4 and K4 is how much? Upon ML3 into L. This can also be represented by a single reaction. How can we write that? Can we write this as like M plus 4L becomes ML4. What will be the expression be for K? ML4 over M into L to the power 4, yes or no? Now can someone give me the relation between K and K1, K2, K3, K4? What is the relation between K? Excellent. K is K1 into K2 into K3 into K4, and this is known as the stability constant. Here you can write it as beta 4. Greater the value of beta, greater will be the stability of your coordination complex. Did you get that? I repeat. Greater the value of beta, greater is the stability. And people, 1 upon beta is also called as the instability constant. या आप इसको बोल सकते हो dissociation constant. Did you will get that? You get very easy numericals. For example, what they will do is they'll give you 4 complexes. Understand कि इस पे questions कैसे आएंगे? They'll give you 4 complex 1, 2, 3, 4, and then they'll say कि there's one complex which has the value of equilibrium constant as 10 to power something, 10 to power something, so on and so forth. All you have to do is find the one which has the greatest value of beta, and that will be the most stable complex. For example, if you want a similar question, एक मिनट booklet देना मेरे को. Open your booklets. And booklet में question number एक में इसको पॉज कर दो रे. Now here, okay, we have 4 complexes along with their stability constant. What we have to do is we need to identify the most stable complex out of the 4. ठीक है. So क्या technique बोला? How do you identify the one with the greatest value of stability constant will be the most stable. समझा? So who has the highest value of K over here, people? So that will be the most stable. ऐसे एकदम simple question आता है इस पर. Did you will get that? चलो. Quickly copy this. Then we continue with then the stability of coordination compounds. People, let's continue. Please write down. Factors affecting stability of coordination complex. Factors affecting stability of coordination complex. Write down the first factor. Smaller the size of the central metal atom, smaller the size of the central metal atom, comma, greater the charge on the central metal atom, smaller the size of the central metal atom, comma, greater the charge on the central metal atom, greater is the stability. Greater is the stability. Next point. Complexes with strong field ligands are more stable. We're just writing key points. So the more stable than the one with weak field ligand. So I repeat, complexes with strong field ligands are more stable than complexes with weak field ligands. Then complexes with weak field ligands. Next point. Complexes with chelating ligands are more stable. Complexes with chelating ligands are more stable. CHELATING. I'll explain what that means. Chelates or chelating ligands are more stable. Chelating ligands लिखा है वहाँ पे ब्रैकेट में write down bidentate ligands forming rings. Bidentate ligands forming rings. यहाँ पे एक एग्जाम्पल देखो पीपल. Now people observe this. Now, so what we have here is ethylene diamine. Okay, and ethylene diamine is a bidentate. So if you see here with Cu2 plus, it forms a ring. Now this is a 5-membered ring. यहाँ पे भी देखो, it's like a 5-membered ring. So ligands, especially bidentates, which can form such rings, are called as chelating ligands. But if you remember, we did something called as Bayer strain in organic last year. So a 5-membered ring and a 6-membered ring, okay, will be more stable. So it's not that all bidentates can form stable chelates. For example, if you look at a bidentate like hydrazine, anyone remembers what was hydrazine? NH2, NH2, excellent. Now here hydrazine, let's say with the same Cu plus 2 will form a 3-membered ring. And 3-membered rings have angle strain. So this is not a stable complex formation. So 4-membered ring or a 5-membered ring or a 6-membered ring. And the reason they have higher stability is, let us say that if this bond breaks, there is still one bond or one side of the ligand which is attached to the central metal atom, and the bond is reformed even if the bond breaks. Did you people get that? Yes or no? Copy this. Possibly. And the last point, central metal atom with pseudo noble gas configuration. Central metal atom with pseudo noble gas configuration. Bracket में write down EAN. So if it's a 3D series element, people, what should the EAN be equal to? 36. So write down EAN 36, 54 or 86 are more stable, which means the central metal atom should reach noble gas configuration. Chalo, now I am writing some questions on the board. You have to arrange these following complexes in decreasing order of stability. Now, so we have to arrange the following complexes in decreasing order of stability. We'll just go through all the rules to understand this. Look at the first question, people. I have K3FeCN6 and K4FeCN6. What's the charge on Fe over here? +3. and plus 2. Ferro. Look at the first rule. What was the first rule? Smaller the size or greater the charge, greater will be the stability. And that's why first one is more stable than the second. Now, look at the second question. K3 FeCl6 and K3 FeCl6. Now over here, Fe is plus 3 in both. Okay. But then how do we decide excellent? This is a strong field ligand and here we have a weak field ligand, making the first complex more stable than the second. Now let's look at this one, people. In this example, there are few complexes which has a bidentate, and bidentate forms chelates. So which one will be the most stable out of A, B, C and D? C, because all the three are bidentates. Then we have D, because there are two bidentates. Then we have A, and the last one we have is B. Now if you look at the last one, on the left hand side we have a tetrahedral complex, on the right side we have a octahedral complex formation is more stable as compared to tetrahedral, and that is why the complex on the right is more stable than the left. Okay, so you get questions like these where you need to probably arrange in descending order or ascending order the stability of coordination compounds. Did you people get that? Chalo, quickly complete this. KP, pause. Okay. So maybe the last topic that we have is identify X and Y and give the structure of the following metal carbonyls. Now, if you look at the first one, people, first complex concept NiCOX. Now, people, we know that Ni is 0 over here because carbonyl is 0. And what is the atomic number of Ni? 28. So number of electrons here is 28. We know that for EAN it has to reach. So how much will X be? Considering this is a monodentate, excellent. X will be 4. So because 28 plus 4 into 2 is going to be 36. Did you get that? And what is the geometry, people? So if I get NiCO4, कौन सा geometry आता है people ये? Excellent. It will be tetrahedral. Did you people get that? First wala. Chalo. So let's try and do the second one. FeCOX. Chalo. FeCOX कैसा था? What will be X over here, anyone? Fe is 26. Again, this is 0, 0. So this is 26. Again, we have to reach what? 36. So how much will X be over here? 5. Because we have to reach the next noble gas. So this becomes FeCO5. Can anyone tell me what will the geometry be for FeCO5? Excellent. Trigonal, bipyramidal. 1 CO above and 1 CO niche. So this will be trigonal bipyramidal. Any questions here? Chalo. Let's try the third one. Pause. Now we will look at the second wala kiya tha na. Look at the third one, people. What is third wala? CrCOX. So what about X over here? Chromium is 24. So we have to reach 36. So how much will X be? So this will become CrCO6 and this will be octahedral or square by pyramidal. Now pay attention carefully for the last two because they are slightly different. What is the fourth one given, people? MnXCO. Now, if I look at Mn atomic number 25. Now I want 25 to reach 36. And with all monodantates, I can never reach 36. Which number will you fit over here x for this to reach 36? Fractional value to डाल नहीं सकते. You cannot put x is 5.5. It has to reach 36. So यहाँ पे क्या करते हैं? Pay attention. See, if I take Mn and if I give 5 ligands to Mn, मतलब 5 CO. So let's say this is bond number 1. So Mn had 25 electrons. You added 2 more. तो अभी कितना हो गया people? 27. How much now? 29. 31. This is like coming out of the boat towards you. 33. So if I add 5 ligands or coordination number 5 कर दूं, it will reach EAN of 30. We want it to reach. हम क्या करते हैं? We repeat this configuration. And there's a bond between the metal and metal. So with the 5 ligands it was 30. Sharing 1 electron with Mn, that becomes 36. In short, what is X over here? This becomes Mn2CO10. Now that's not the only way to reach this. There can be multiple different configurations. For example, you can take MnCO5 and this is also 36, or you can take MnCO6 and +1. Did you get that? So they can ask anything. So ऐसा various combinations you can try. I want the fifth one. आप लोग try करना. CO. So this is X and this is. Remember, if you try to do it direct, CO is 27. You cannot take it 36. Even number of COs add करेंगे तो. You have to follow the same approach that we have done here. कैसे करेंगे? CO. If I add 4 of these, 4 carbonyls. So 4 carbonyls mean 8 electrons. So 27 plus 8 will become 30. This becomes 1. Or you can write this as COX COY. So X is how much over here? 2. And Y is how much, people? 4. Yes or no? Or if I take for homework, I want you to try ये वाले combinations where you give the complex, where you make a cationic or an anionic complex of CO and carbonyl. Did you people get that? Jaldi copy this for me. Pause that. Please write down, people. The last topic of the chapter, colors in coordination compounds. When white light is incidented on a complex, when white light is incidented on a complex, the ion absorbs a small amount. The ion absorbs small amount of incident light, absorbs small amount of incident light, and the remaining portion is transmitted or reflected. And the remaining portion is transmitted or reflected. Transmitted or reflected. The ion absorbs small amount of incident light and the remaining is transmitted or reflected. The colors of transmitted and reflected light is complementary of each other. And people remember we did this in D block. How do you identify the absorbed and the complementary color? याद है वो? So if blue light is absorbed, the complementary color will be orange. Let's say if green light, if you see green light, that was the, so the complementary of green was red. Yaad hai people ye? Yes, we did this in D. Copy this. Of each other. We have to copy that. Yes. Chalo, write down. Many of the coordination compounds are colored due to the phenomena of due to the phenomena of DD transition. For example, the example is on the board. And the last point, in complexes where, in complexes where the central atom contains filled d orbital, or empty d orbital, filled d orbital, or empty d orbital. The color is due to what was the second reason, people? Excellent. LMCT, ligand to metal charge transfer. LMCT, ligand to metal charge transfer. So people, this completes the chapter. Next class we start with electrochemistry. Thank you so much.